The psychrometry is a branch of engineering science which deals with the study of moist air, i.e. dry air mixed with water vapor or humidity. It also includes the study of behavior of dry air and water vapor mixture under various sets of conditions. Though the Earth's atmosphere is a mixture of gases including nitrogen, N2, oxygen, O2, argon, R, and carbon dioxide, CO2, yet for the purpose of psychrometry, it is considered to be a mixture of dry air and water vapor only. Psychrometric terms. 1. Dry air. The pure dry air is a mixture of a number of gases such as nitrogen, oxygen, carbon dioxide, hydrogen, argon, neon, helium, etc. But the nitrogen and oxygen have the major portion of the combination. 2. Moist air. It is a mixture of dry air and water vapor. The amount of water vapor present in the air depends upon the absolute pressure and temperature of the mixture. 3. Saturated air. It is a mixture of dry air and water vapor when the air has diffused the maximum amount of water vapor into it. The water vapors usually occur in the form of superheated steam as gas. However, when the saturated air is cooled, the water vapor in the air starts condensing, and the same may be visible in the form of moist, fog or condensation on cold surfaces. 4. Degree of saturation. It is the ratio of actual mass of water vapor in a unit mass of dry air to the mass of water vapor in the same mass of dry air when it is saturated at the same temperature. 5. Humidity. It is the mass of water vapor present in 1 kilogram of dry air, and is generally expressed in terms of gram per kilogram of dry air, g/kilogram of dry air. It is also called specific humidity or humidity ratio. 6. Absolute humidity. It is the mass of water vapor present in 1 cubic meter of dry air, and is generally expressed in terms of gram per cubic meter of dry air, g/m3 of dry air. It is also expressed in terms of grains per cubic meter of dry air. 7. Relative humidity. It is the ratio of actual mass of water vapor in a given volume of moist air to the mass of water vapor in the same volume of saturated air at the same temperature and pressure. It is briefly written as RH. 8. Dry bulb temperature. It is the temperature of air recorded by a thermometer when it is not affected by the moisture present in the air. The dry bulb temperature, briefly written as dBT, is generally denoted by TD or TDB. 9. Wet bulb temperature. It is the temperature of air recorded by a thermometer when its bulb is surrounded by a wet cloth exposed to the air. Such a thermometer is called wet bulb thermometer. The wet bulb temperature, briefly written as WBT, is generally denoted by TW or TWB. 10. Wet bulb depression. It is the difference between dry bulb temperature and wet bulb temperature at any point. The wet bulb depression indicates relative humidity of the air. 11. Dew point temperature. It is the temperature of air recorded by a thermometer when the moisture, water vapor present in it begins to condense. In other words, the dew point temperature is the saturation temperature. Sat corresponding to the partial pressure of water vapor, P. It is usually denoted by TdP. 12. Dew point depression. It is the difference between the dry bulb temperature and dew point temperature of air. Humidification. The addition of moisture to the air without change in its dry bulb temperature is known as humidification. Dehumidification. The removal of moisture from the air without change in its dry bulb temperature is known as dehumidification. Air conditioning system. The air conditioning is that branch of engineering science which deals with the study of conditioning of air. Supplying and maintaining desirable internal atmospheric conditions for human comfort, irrespective of external conditions. Factors affecting comfort. Air conditioning. 1. Temperature of air. 2. Humidity of air. 3. Purity of air. 4. Motion of air. Central air conditioning system. Central air conditioning, or central /C, is a system in which air is cooled at a central location and distributed to and from rooms by one or more fans and ductwork. It is adopted when the cooling capacity required is 25 TR and more. It also adopted when the airflow is more than 300 m3/min or different zone in a building are to be air conditioned. Central heating system. Type of piping used. 1. Two-pipe system, hot or chilled water at a time. 2. Four-pipe system, hot and chilled both at a time. Hot water generation equipment. 1. Electric hot water boiler. 2. Oil/gas-fired hot water generator, boiler. 3. Reversible heat pump. Heat load calculation. The total heat required to be removed from the space in order to bring it at the desired temperature by the air conditioning and refrigeration equipment. The purpose of a load estimation is to determine the size of the air conditioning and refrigeration equipment that is required to maintain inside design conditions during periods of maximum outside temperatures. Thumb rule. For room. For residential equals area square dot mount x 0.06 factor. For commercial equals area of room square dot mount x 0.07 or 0.08 factor. For industrial equals area of room square dot mount x 0.09 factor. For people equals no of people x BTU/r/person 250 approximate. For equipment load equals no of equipment x load x 3.41 factor. Air conditioning plant. Air conditioning plant means the plant, machinery, and equipment installed in the building for heating, cooling or circulating air in the premises and any alteration, addition or replacement of this plant, machinery, and equipment. Types of a .C plant. 1. DX unit. 2. Chilled water /brine unit. DX system. In DX system, the refrigeration is directly responsible to cool the air. Chilled water system. In chilled water system, first the water gets chilled by refrigeration, then chilled water is responsible to cool the air. There are two methods to condensate the refrigerant. 1. Air-cooled condenser. 2. Water-cooled condenser. DX unit, air-cooled. 1. Window AC non-ductable. 2. Split AC non-ductable. 3. Split AC ductable. 4. VRV system can be either ductable or non-ductable or a combination of both. 5. Rooftop unit. 6. Condenser-less self-contained package unit ductable. 7. Precision air conditioner. DX unit, water-cooled. 1. The only water-cooled DX units currently in use are package air conditioners. 2. These units are ductable type and require a small enclosure for housing them. 3. They require cooling tower, condenser water pump. Compressor used in DX unit. 1. Reciprocating window A.C, split AC. 2. Rotary window A.C, split AC. 3. Scroll VRV unit, rooftop unit, condenser package unit, process-ion unit. 4. Screw precision unit. Chilling unit. 1. Air-cooled chiller. 2. Water-cooled chiller. Package air conditioning. The window and split air conditioners are usually used for the small air conditioning capacities up to 5 tons. The central air conditioning systems are used for where the cooling loads extend beyond 20 tons. The packaged air conditioners are used for the cooling capacities in between these two extremes. These units are used commonly in places like restaurants, telephone exchanges, homes, small halls, etc. As the name implies, in the packaged air conditioners all the important components of the air conditioners are enclosed in a single casing like window AC. Thus the compressor, cooling coil, air handling unit, and the air filter are all housed in a single casing and assembled at the factory location. Depending on the type of the cooling system used in these systems, the packaged air conditioners are divided into two types, ones with water-cooled condenser and the ones with air-cooled condensers. Packaged air conditioners with water-cooled condenser. In these packaged air conditions, the condenser is cooled by the water. The condenser is of shell and tube type, with refrigerant flowing along the tube side and the cooling water flowing along the shell side. The water has to be supplied continuously in these systems to maintain functioning of the air conditioning system. The shell and tube type of condenser is compact in shape and it is enclosed in a single casing along with the compressor, expansion valve, and the air handling unit including the cooling coil or the evaporator. This whole packaged air conditioning unit externally looks like a box with the control panel located externally. In the packaged units with the water-cooled condenser, the compressor is located at the bottom along with the Condenser, refer the figure below. Above these components the evaporator or the cooling coil is located. The air handling unit comprising of the centrifugal blower and the air filter is located above the cooling coil. The centrifugal blower has the capacity to handle large volume of air required for cooling a number of rooms. From the top of the package air conditioners the duct comes out that extends to the various rooms that are to be cooled. All the components of this package AC are assembled at the factory site. The gas charging is also done at the factory. Thus one does not have to perform the complicated operations of the laying the piping, evacuation, gas charging, and leak testing at the site. The unit can be transported very easily to the site and is installed easily on the plane surface. Since all the components are assembled at the factory, the high quality of the packaged unit is ensured. Packaged air conditioners with air-cooled condensers. In this packaged air conditioners the condenser of the refrigeration system is cooled by the atmospheric air. There is an outdoor unit that comprises of the important components like the compressor, condenser, and in some cases the expansion valve, refer the figure below. The outdoor unit can be kept on the terrace or any other open place where the free flow of the atmospheric air is available. The fan located inside this unit sucks the outside air and blows it over. The condenser coil cooling it in the process. The condenser coil is made up of several turns of the copper tubing and it is thinned externally. The packaged ACs with the air-cooled condensers are used more commonly than the ones with water-cooled condensers. Since air is freely available, it is difficult to maintain continuous flow of the water. The cooling unit comprising of the expansion valve, evaporator, the air handling blower, and the filter are located on the floor or hang to the ceiling. The ducts coming from the cooling unit are connected to the various rooms that are to be cooled. VRF/VRV. Variable refrigerant flow, VRF/VAC systems consist of outdoor units connected to multiple indoor units via refrigerant piping to provide cooling and heating to individual zones. The outdoor units can modulate capacity based on the requirements of the individual zones, thus saving energy by not always running at 100% capacity and improving occupant comfort by maintaining temperature as needed in each individual zone. The refrigerant flow is varied using either an inverter-controlled variable speed compressor or multiple compressors of varying capacity in response to change in the cooling or heating requirement within the air-cooled space. Drive used in compressor, fan motor. 1 VSD variable speed drive. 2 VFD variable frequency drive. 3 CFD constant frequency drive. Working principle. The indoor temperature sensor, according to actual load of the indoor units, controls the electronic expansion valve on the refrigerant medium pipe of the indoor unit, and it controls the compressor of the outdoor unit according to the change in the refrigerant medium pressure. varying the refrigerant volume of the system. In his way, the AC can adjust itself automatically to meet the needs of the change in indoor load, so as to attain the goal of conversing energy. Chiller. A chiller is a machine that removes heat from the liquid via vapor compression or absorption cycle. In this AC system, the chilled water from the chiller is distributed to heat exchanger or cooling coils in the air handling unit, FCU, and the hot water is returned back to the chiller. Note: 1. In air-cooled chiller, the condensing unit is cooled by atmospheric air by the means of condensing fans. 2. In water-cooled chiller, the condensing unit is cooled by water, and the water gets cooled by the means of cooling tower. 3. Base foundation and spring isolator are required for installation. Air-cooled chiller. The chillers will produce chilled water, which is pumped out around the building to the air handling units, AHUs, and fan coil units, FCUs, which remove the unwanted heat from the building and transfer it into the chilled water loop. The chilled water will enter the AHUs/FCUs at around 6 degrees Celsius, 42.8 degrees Fahrenheit, and by the time it leaves the heat exchanger within the AHU/FCU, it will have risen to around 12 degrees Celsius, 53.6 degrees Fahrenheit, and will then make its way back to the air cooled chiller to dump this heat into the atmosphere before repeating the cycle. The warm return chilled water